All right, so let's get started. Today's topic is migrating a monolithic front end to multiple micro-frontends. My handle is at Zackary Therrien. That's also my name. You can find me on LinkedIn, Twitter, and Instagram. This presentation is hosted by Acidia. So do check it out, acidia.com. So for micro frontends, this really comes from this question or this fact, I guess. New technologies will come out tomorrow. So you have a choice of either stagnating or migrating some of your code. Yeah, you don't want to stagnate. So you should probably migrate stuff. Unless you do want to stagnate, like it's a possibility. This is really a story of some of our projects, especially my project since 2017, maybe some of your projects, and a lot of other companies. So Uber, Spotify, HelloFresh, Netflix, IKEA, and SoundCloud all use micro-frontends. There's probably hundreds of other companies out there and other projects that use micro-frontends as well. They're a really good tool to distance yourself from existing code. And so it allows you to be a bit more flexible. So as I said, this is the story of my project. It's been 5 years now. And as you can guess, over 5 years, technology has evolved a lot. TypeScript 3 was not even out at the start of the project. And various other technologies. We've built 500,000 lines of code during that time and 3 big applications with multiple sub applications for each of those. So this really comes from separating the domain into 3 applications, and in those we have sub applications. Over the last 5 years, yeah, it's been nonstop programming basically, and architecting and designing. Sorry, I have to like accept all of these people at the same time. But yeah, so nonstop with very little hindsight. The project had a lot of confusion, even from the client's perspective. Things were not 100% clear all the time. So you can kind of imagine that something that is pretty small, when you start a project, you're basically starting with a blank screen. And so as it grows, you get bigger and bigger software. And you know, in most projects, this usually starts off as a proof of concept or an MVP, a most viable product. And the idea is usually, well, just ship it, right? Just send as much code as you can, deliver as much code, deploy as much code as you possibly can, so that you get return on investment fairly quickly. Now, there's various issues with that, and I guess we can kind of inspire that conversation by what I've seen in my project. Maybe it's your project as well. I would not be surprised. So in general, you know, you go from a front-end repository, a back-end repository, and both of those kind of get monolithic over time, right? They just grow. You can also go towards poly repos. So you could get, you know, 15 repositories or more if you split it up based on Git repos. But the idea is over time, if nothing is done, it just becomes monolithic. And I guess monolithic in itself just means there's a lot of complexity. Things are kind of starting to be hard to develop with. And so, yeah, monolithic. In our case, we had 15 repositories, and 3 of which were huge. And by that, I mean the front end, the back end, and something called calculation repositories were gigantic. And it was actually hard to keep code drift in sync. So between the front end and the back end, there's a lot of friction there. because it's in separate repositories, it's hard to keep track of what change will have what effect. You could implement tools, but in general, code drift is harder to manage in poly repos, especially if they're monolithic. Now, we had thousands of front-end components. We are using React. Tech and dependencies were not necessarily updated. Some of the times it was actually not feasible to update. So having thousands of components, upgrading to React hooks, let's say, from React classes was it's not really feasible in a short time frame, especially if you have to keep developing new features. So that's, kind of tied in with no substantial refactoring. If the decision not to refactor is made, then that's one issue that micro-frontends could solve down the line. If you hear people in your team say something like, we should rewrite the entire thing, that's most likely a sign that there's an issue either with your monolithic application or that you need to find new solutions to what you're doing. One of them, micro-frontends again. Another good problem that micro-frontend solves is techno-locked stack. And I'll come back to techno-locked stack in just a moment. Now, in the previous slide, I said, let's just ship as much as we can. And obviously, when you do, you still make things pretty. So your client or your project sponsor or product owner, they see this beautiful foliage, this beautiful tree, but what they may or may not understand is the complexity that lies underneath. So that's pretty analogous to a root system of a tree. It's kind of ordered. It goes from a very big trunk to smaller roots, and then to even smaller. So there's that natural progression, same complexity here with software. Now, techno-locked stack, what does this mean? It means that you're locked in a stack from before, or you can't move away from a stack. So something like Angular to React, or in our case, in June of 2017 is the start of a project. And we went from something called FlowScript, which was developed by Facebook and is the precursor to TypeScript. And so in July 2018, when TypeScript really started being popular with the release of TypeScript 3, our project was already started. There was already thousands of components. And so switching from Flow to TypeScript had various issues. And then TypeScript 4 in 2020, and same thing for, let's say, React classes to React hooks. Now, technically, you don't need to upgrade because React does allow for backwards compatibility for some of these things. But if you remember from React 16, you had things like component did mount, unsafe, will update state. I don't really remember the obscure functions, but we had a bunch of those. And so just upgrading to 17 was a hassle. Redux, Webpack, all of these good things, whether it's at the build time or else. Compiler, even in CI, you could have the same problem in CI where if you've built your entire CI for GitHub, well, and you switch to GitLab, you're gonna have to rewrite that whole thing because you're techno-locked to the GitHub CI. And they probably actually want you to be techno-locked to their systems as well. So what's the issue? 15 repositories, 3 of which are huge monolithic, thousands of components, et cetera, et cetera. Well, you get to something that looks like a real ball of mud. Now, you've heard about real balls of muds before. So basically, there's dependencies everywhere, and you don't know how one change will affect the rest of the system. Yeah, very complicated. Now, you can imagine that if you have a front-end repository and a back-end repository, where you have that distinction right down the middle, and code drift kind of just increases if you don't have tools to manage that. And even if you do have tools, there's still a bit of friction there. So you do end up with two balls of mud. It's not great, but I guess it's slightly better because you can have independent technologies here. So your backend could be in Python or PHP, hopefully not PHP, please don't. Node probably is slightly better. And your front end in whichever framework that you're interested in. Now, I started my presentation with this title, so migrating a monolithic front end to multiple micro-frontends. But it's kind of a lie. Depending on how much budget and time that you have, you'll actually end up with a monolithic front end plus some micro-frontends around the monolith, or at least that's how you're going to start. If you already have one in place, you can't just say, okay, well, I'm going to split everything apart and create micro-frontends for everything, unless you have unlimited time, unlimited amount of developers, or budget. So if you do, then you can take your existing system, split it up, and migrate everything all at once. But in general, what's going to happen is you have your monolithic front end and you build around it. And hopefully while you're creating your new micro front ends, you kind of stop building on top of the existing monolith, so that the more that you build on top, the more fragile it could become. And so you want to avoid that to prevent the eventual crash. And what does the crash look like? Well, it looks like this, right? If you end up with a ball of mud, that's the problematic that we want to solve. So what is a micro front end? Well, it's very analogous to a microservice. And I'm sure you've heard of microservices. They've been around for maybe 2 decades now, or more. So the idea is to take a big thing and to split it up into smaller things. So in this case, if you can think of the poop emoji, you're going from a very high volume because of the surface area of the shape to a smaller volume because all of these microservices have a smaller size. So that's the goal, is to reduce the amount of the volume that you have. Extrapolate that a bit, and you have microservices and micro frontends at the same time. So kind of there's 2 options when talking about MFEs. There may be more, but these are the 2 that I've been thinking about. And it's, a client comes to you with new requirements and new requirements to either build something new, so creating a new application, or there's also migrating some existing application towards micro frontends. So creating a new app, basically you're integrating your existing system. You're integrating this new application with your existing system using an MFE. The MFE standing for micro frontend. Micro frontend is just a tool, or you can also consider it a technology, where your application is contained, right? So it's one box among all of the boxes. Hopefully it also has its own backend, but even better would be for it to have its own set of microservices. You can also technically use your monolithic backend, but or your existing microservices, but hopefully you kind of stop using the monolithic backend and start creating your microservices, unless there's no changes required to the backend itself. To migrate an existing application, sometimes this is useful, mainly if new requirements come in that have slight changes in, let's say, domain, and existing technical debt does not allow you to add those new requirements to the domain. And so migrating an existing application or a sub-application towards an MFE and then integrating that into the rest of the system. So you would rewrite it. You could copy paste it if you're very lucky. Yeah, if your technologies are properly set up, you could copy paste it or use some tool to automatically kind of analyze the code and modify it to fit your new tech stack. While you're migrating, might as well fix some bugs that you've identified, improve some capabilities, improve performance, include those new domain requirements as well. So migrating to MFEs, it's actually pretty time consuming, and you would want to get it right the first time, but honestly, you're probably not going to get it right the first time, and that's okay. The idea is to move in the right direction and to keep moving towards the right direction over time, and not necessarily to have the right answer right away. And one of the kind of ideas to keep in mind is that some of the systems that you build will remain for a very long time. One of those is banks. Banks still use systems built in the 1970s using obscure languages like COBOL and Visual Basic, etc. And those technologies, those languages are still, talent recruiters are still looking for people that have that knowledge, and they're paid a lot because there's not a lot of them, but banks still need those developers to maintain the existing systems to fit with the new ones that they're building. So as you build new things, keep in mind that it may stay for a long time. Migrating to MFEs, it's time consuming, especially if you have millions of lines of code. It's something to consider because it's not easy to migrate millions of lines of code, even if you do have an automated tool that will kind of refactor for you. I guess maybe GPT-4 could help you with this. Yeah, if you already have the knowledge and the domain program, could be feasible to use GPT-4. So maybe in the future, this is going to be much easier than today, at least. Also, changing frameworks is really difficult. Angular to React has a bunch of differences. You might as well just rewrite. And some people do choose to do that. Hopefully not too often, but yeah. Now, migrating to MFEs, something to kind of look at is what you want to migrate. What do you want to, well, migrate and or create, right? Being realistic with your client about what the migration would entail or what the creation does entail is always an important step in your development cycle. So identify what you want to migrate. Then you probably want to validate the context boundaries between your application. You don't want to increase the technical debt that you have. And one way to verify the boundaries of your applications is something called domain-driven design. It's out of scope for this conversation, but that's one tool that you can use to validate those context boundaries. The idea is to have very lean interfaces between applications. So after you've validated, you've identified, you would build either the application or you would migrate your existing application. In this case, you can build the application. You should definitely, if you're going the MFE route, take a look at your CI/CD. Make sure that it's up to date and ready to handle a large influx of services and front ends. Same thing for, let's say, microservices. Good luck trying to deploy 50 MFEs manually. You could do it, but that's not the goal. The goal is to automate as much as possible. And if you need to do this manually, then MFEs are probably not the right solution. You're probably like a one-man team or a woman team. So yeah, try deploying 50 MFEs manually. Good luck. And while you're building and extracting and validating the context boundaries, you need to kind of ensure that the interface between your applications, so the communication between them is small as possible, means that it's more maintainable. If you have a very large interface, you have a lot of points to verify across, or props, or whatever you want to call them. And if you don't have any interface between the two, then you probably have two completely independent applications, in which case, you should probably decouple that entirely, hopefully. And then you just repeat, right? So if you have an existing code base and you want to move away from that, and you want to decouple things as much as possible, then you keep migrating your old applications into different MFEs. Keep that in mind. And this is very analogous to a technique called strangling the monolith. So I recommend you take a look at that online. It's a very good read. And the idea behind strangling the monolith is that you take kind of a portion of it, you've identified a portion of it, you extract it out, you move it outside of the monolith, maybe just copying it to a different folder as a first step can help you out. And when that's done, you really create, the whole structure around it, and you add the connection to your existing system. So you're going to have to modify the existing one just a bit to add that connection. But in general, it's worth it to do that small modification at the boundary of the interface between the MFE or microservice, because it's almost a one-to-one analogy between microservices and micro-frontends. The only difference is, where does the code live, or where is it executed, I guess. So you've built out a few MFEs, you've separated them from your monolith, and you have 3 different applications that you've identified and been able to extract from the existing structure. Your about system or application, your cart application, and the shop application. And these are independent from each other. There's no lines between the two, but as you can see, there's something hidden behind here, and that is something called the host. So with most MFE structures, I'm not quite sure if all of them, but definitely most, you're going to have something called a host that will take care of rendering or positioning the applications and how they're linked together. In this case, you can think of the host as the e-commerce website, and the e-commerce website would say, okay, well, the about application is in /about. The cart is in the top right with a little icon that is rendered by the cart itself. And the shop is the rest of the main page. And that would be determined by the host. You could also have a host, like shop could be its own host as well for another MFE below it. It's definitely possible to have MFEs within MFEs. Hopefully you don't get too lost with like MFEs within MFEs even further down, or cyclic MFE references. Could be cool though to have a system like that. Some of the good tools to help you out in your quest to micro-frontends or else, we have NX, which is one of my favorites right now. It's a monorepo tool, but it allows for micro-frontends, dynamic micro-frontends, so kind of switching front-ends at runtime, server-side rendered micro-frontends, which is also really cool. Webpack 5 is a tool that allows you to have MFEs through module federation. And there's others as well. Netflix Lattice is one of them, but I'm not quite sure that it's public. So yeah. Oh. And some of the tools of MFEs itself are not limited to micro front ends per se. They could be single components or the entirety of your UI library. So you could think of your UI library being dynamically loaded at runtime, or doing dynamic dependency injections. So yeah. If you can't use a tool, or you want to know how these tools work, we'll take a look at some pseudocode in just a moment. In general, if someone does say we can't use a tool, this is most likely because they're techno-locked to, their stack is techno-locked to maybe 2016. Maybe it's a pure HTML web page in with tables of 1996, right? So they can't use these new tools, but you could actually build it yourself using, you could build it yourself, yeah. And the pseudocode that I'm going to show you is how module federation works under the hood, and how NX micro-frontends also work under the hood. So hopefully you see VS Code. I don't know if it's working or not. Okay, yeah, it is. Perfect. So let's just take a look at these files here. We have the monolithic application, and how React works is basically you have an HTML, right? You need to have an HTML tag, and you have a div that has a root, an ID of root, so that you can identify later on. You could not have an ID if you wanted to, but regardless, there's an ID, root. You grab that element in your TypeScript or JavaScript code, and you would create a React DOM, or you would create a React root using the React DOM package. And to do that, you would pass in the div that you want React to be rendered in, or where you want React to render your components in. Yeah. So how does a micro front end get loaded? Well, this is the MFE interface that I was talking about in a few slides prior. In this case, we're using class-based components because we are techno-locked to that. We could, because this lives in the monolith, so you can't use hooks, or you can't use these functions. So you have that, your component in mount. So once your host monolith application knows where to render your micro front end, it will mount it. But first it's going to render a div in there. And you can see that the div with ID myMFE is very similar to what you have over here, div of ID root. Now, when that loads, you would load your MFE files, and then you would mount the MFE. You kind of have these two files, these two functions. Now, you may be asking, well, how do you load these files? Essentially, what you want to do is just load the scripts for your application, for your MFE. And if you've ever looked at the asset manifest file of some of your compiled applications, you'll see that it's basically a list of files with the initial entry point of your application. So in this case, you would be able to do a request to grab that asset manifest that would tell you what the files are and what the path is for those files. And you would append the script, load it, wait for all of the scripts to be loaded. And when that's done, you kind of use a, you would use a variable on either the window or the global this. Technically, you should not, and that's why there's a cleanup down here. And this is also pseudocode. If you use these tools like Webpack and NX's MFEs, you don't have to do any of this. I'm just saying this is how they do it under the hood with probably better techniques. And yeah, in general though, the concepts are the same. You would have a function that is stored on your window that you can call to mount your MFE. At the same time, you can pass in some props. And the my MFE here is the ID of the div that you want to render your new application in. I think that you could probably just pass in your div as well, my MFE div instead. The MFE itself, so that was all in the monolithic repository. All of this concept. If you switch over to a new MFE, so you're in a new repository or you've created a subfolder and this MFE has new technologies, basically you have the same setup. So when you want to run it locally, you would use an HTML, a body, and HTML, and a div in there, and you would render a React root with your MFE application. So this is pretty much a copy paste of what we have over here in the monolith. Right, so the only difference is the variable name and the container ID of the root. Now, the funky method that we have over here that's called mount MFE function actually comes from your index.tsx of the MFE. And what it basically does is you give it an ID for your div, you grab that ID, you render it, and you pass in some props if you wanted to. Obviously, do some cleanup and handle unmounting when that's the case. Yeah, so this is for when you want to interface it with the host application, and up here is if you want to run it locally. So running a React application is exactly the same thing as running an MFE locally. The nice thing about MFEs is that you can run them independently from one another. If you have a very big application, this may be necessary because your local computer may not have enough power to either watch all of those file changes or recompile them, a combination of both, or run the application itself because it's too computationally expensive. So yeah, you can run them independently and view them in your browser in a different tab from your host. So that's how Webpack and NX display those MFEs to bundled applications. Obviously better than that, and you should probably not use this pseudocode exactly as it is. Just use the tools, and if you're technolocked, take a look at what you can do from the existing technology, or add a new package that does it for you, if you can, if you're lucky. Now, there's a bunch of warnings with MFEs, and I'm still finding some every single day, but it's kind of the same thing as microservices. They come with their own challenges, and they may not be the right tool for you. If you're a small application or a small team, MFEs may not be the right answer. But if you are a large team or you have multiple teams, then they're definitely an option for you. Auth is pretty hard with MFEs, kind of similar to microservices. How do you handle auth? You could technically store your JWT in local storage, but that's probably not the long-term solution that you want to implement. If you do have, and you do use MFEs, one of the things that you'll notice is that you may have multiple runtimes. One of them is, let's say, your host React, which is version 16, and the other one would be your MFE with React 18. So in that case, you're downloading React twice, but with different versions. And that may lead to other issues down the line. Same thing with styled components. If you have styled components twice, then that's problematic. You can do something called external dependencies, which is a potential option. More loading screens. So technically, when you load an MFE, so let's say you're navigating in this application, right, and you hit a page that has an MFE in it, you're gonna have to fetch those files from the server, fetch the MFE files, so the main.js, the vendor.js. And while that's happening, you have to show a loading screen. And then afterwards, you mount your MFE, right? You've loaded it. And then you may have more loading screens because when your application starts or your MFE application starts, you have to go and fetch the data for that application. So you're adding one extra layer there. In most cases, what you can do is caching the MFE files. So the asset manifest files that you saw a few seconds ago, that caching happens on the client side. So you let Chrome handle that, or you could also do build time integration. But the problematic with build time integration is that you're basically coupling your application at build time. So you're not actually having independent applications. You don't do dependency injections. You're just coupling it at a different moment in the build cycle. So it's feasible if loading screens is really not possible, or let's say that your users are offline or your application has to be offline, then build time integration is possible for those use cases. And yeah, don't use iframes. It's terrible UX. There are security vulnerabilities. Not fun. And the biggest warning that I have for MFEs is state sharing. And state sharing is really hard in MFEs because they're independent applications. Or at least they should be, right? So you shouldn't really share state. You can do it at multiple different levels. One of them is that the props or the parameters that are added to the mount function at the start of the mount. You could also use global states applications like Redux, but that may not work as expected if you use local storage. Don't use local storage. You could also use the Chrome database, in-memory database, I guess, but the idea is not to share state with other parts of your application. It's to use probably something called PubSub. If you've heard of PubSub for microservices, it's very similar for micro-frontends, but just in the front end. So state sharing is equal to coupling. That's as easy as that. If you're going the micro-frontend route, you're doing it because you want to reduce the coupling between systems. And if you share state, then you have to keep track of the state differences or the state structure, the DTOs, etc. So this could be, this increases coupling between your systems. The real solution is PubSub for MFEs. So yeah, MFE, independent application, independent state. Maybe the best option. Was there anything else? Yeah, so reaching the end here, while I was writing this, I kind of extrapolated to 2030. And yes, 2030 is in like 7 years. That's crazy. Time flies. Scary. But 2030, what's next? Well, Next.js is doing server-side rendering. If you extrapolate that just a bit, you have server and client components from React or Next.js. And those are called RSC, React Server Client Components, I think. Take a look at that. They're probably the future of what you want to do. They're basically a combination of micro-frontends and microservices in one file or in one deployment, in one concept. And then you can have, let's say, your server component that renders client component that has inside of that server component. So microservice that's rendering a micro-frontend that's using microservices and creating their own microservices. It's a pretty nice concept. Edge computing, and we're basically kind of moving back towards distributed mainframes where you know, you're letting a server doing all the server side renderings, or at least as much as possible, and you're just shipping away the HTML and the built application. So and distributed because of the edge computing aspect of it, where you can have multiple servers doing the same thing. Hopefully your apps are decoupled by 2030 because yeah, that's my wish for you, is that your applications are all decoupled and your monolith was strangled and everything was split apart into multiple micro-frontends and microservices. I think that's the dream of any developer. May not be the reality though of many. That's it for me today. If there's any questions, I'm not quite sure if there